Hey folks, welcome out there on this nice summery afternoon. We hope that you are tuned in here to TNLearn Mathline. Hey, it's summer school. I'm Ernie Roberts. I'm your host for this session of TNLearn's Mathline Summer School. We have a laid-back atmosphere for summer school. Yes, we do. And you know what? We've got some fun going on today. So let's check out this subject that we're going to be looking at. All for one and one for all. Notice the one is emphasized there. I think that's a hint that we're going to see a lot of ones popping up in our work today, all right? So get your pencil, get some paper, get a calculator, and let's sit back and let's do some fun math, all right? Hey, first problem we've got going on today is a problem that is raging all over the internet right now, okay? It's the rage. It has been crazy. I even had my producer sent this to me and said, you need to put this on a show, all right? And I looked at it and I said, you know, it goes back to the good old, please excuse my dear Aunt Sally, which my director also loves. So we're going to just put this all together and make one nice problem out of it here, okay? Now, I'm taking a little liberty here. Notice I've got a parenthesis around. I'm going to show you what it looks like on the internet. It says 9 minus 3 divided by 1/3. That's where we're looking at it there, okay? Because unfortunately, not always do we have these little symbols at our beck and call. And then we're going to add this 1 onto the end, all right? So there's what the problem actually looks like. And people are getting all sorts of different numbers, evidently. We're going to take you to that. Guess what the title of the day's lesson is? One for all and all for one. We're going to show you that actually equals 1, all right? This is going to be exciting. Now, let's go back to what I mentioned, those please excuse my dear Aunt Sally. Notice I put these in parentheses. The internet did not, but when you have a fraction, it's considered as one entity, so it's like it's already in a parenthesis. So we're not trying to say 3 divided by 1 and then divide by 3, which what some people put on their calculator, and we'll see that doesn't work, all right? So here's the deal. When we work with my dear Aunt Sally, you say, what in the world does that have to do with it? It has order of operations. So we do parentheses, we do exponents. We don't see any of those in this problem at this point. But what we've got to do is, my dear Aunt Sally is about multiplication and division. Multiplication and division, those operations, is called order of operations. Some of you know it at PEMDAS. Now, multiplication does not come before division. They come left to right, okay? Again, those are they're just grouped together. MD, you do whatever comes first. In this case, we've got a division only. But what's the rule? When we got to divide by 1/3 or divide by a fraction, we get all excited here. And we remember from our olden days, we use a reciprocal and we change the divide to multiply. So the reciprocal of 1/3 is 3. And then we're going to tack on this plus 1. Now, at this point, we're with multiplication. That's pretty easy. 3 times 3, that, folks, is where you go first. Don't go 9 minus 3 first. It's not a left to right situation. We have to go where the problem tells us to. And multiplication takes precedence over adding and subtracting. So let's see what we've got. We've got 9 minus our 9 plus our 1. Oh, we're looking good, aren't we? 9 minus 9. Now it's left to right. Now, yes, it said Aunt Sally, but addition and subtraction are all treated equally from left to right once there are no parentheses or anything else left. So we've got 9 minus 9, which is 0, plus our 1, which guess what? It gives us all for one and one for all. Let's check this out on the graphing calculator. See if it knows what to do. It needs to have parentheses, by the way, folks. So some of you are maybe putting this in on your calculator. If you do not get that 1/3 in a parenthesis, you are going to struggle with this. All right, so let's do it. We've got 9. We're going to subtract. We're going to subtract 3, and we're going to put the divided by, and we're going to put in parentheses. Remember when I said you got to put that in parentheses? If you don't, the calculator determines a different kind of order of operations. So that's very, very important right there. And we'll pick up a plus 1, and we're going to see if it knows what to do. We hope it does. Hope it does. Let's see. Enter. Drum roll, please. Here we go. It is 1. Yes, it does check out. But that's the key thing. If you're just typing that into the calculator and you forget the parentheses, let's see what would happen. We'd say 9. We'd say minus 3. We'll hit that divided by 1. And then we'll divide by 3. Which calculator, and you can figure this out if you were to make those all division signs, and then plus 1, but that's the catch. There's a difference. That parenthesis makes all the difference. We get 9 instead, all right? So when you see that coming across the internet, you say, I got the answer right, and I watch Mathline. I know how to do it, okay? So, but that's our first problem. It's all for one, one for all, And that's just it's just one of those nice things that we have, a little bit of fun that comes up on the internet. Got a little situation here for you. I want to look at a problem. You can say, what does this have to do with one? We're going to see in just a minute. Got a story of Joe here. He put $1,000 under his mattress. He might have put it in a safe deposit box. He might have put it in a safe of some sort. But he left it there for 5 years. How much money will he have at the end of 5 years if someone doesn't steal it? Of course, if you got the mattress, sometimes things have a tendency around the house and the family finds, that's some money. I like that. I could use that. But if no one steals it and he keeps the same amount and it doesn't have a chance to do any investment, it just sits there and sits there. How much money will he have? Well, guess what? He's going to have $1,000. He didn't lose anything, but he sure didn't gain anything. He has it for a rainy day, perhaps, all right? And it looks like he didn't waste any money by putting it under his mattress. Now, if he puts it in a safe deposit box, he's actually going to lose a little money because he's got to pay for the safe deposit box, all right? Costs a little bit to do that or to buy the safe. But in this case, we've got $1,000, and that's what we've got to work with. Now, my point is, how do we get there? How do we make that money grow? Or in some cases, how do we make it depreciate? How do we make it go down? So let's take a look at some situations, all right? Let's see. With the first situation I want us to go is back to the number 1. And this is what we're going to hit. 1 raised to any power will be 1. You say, well, Ernie, what does that have to do with the mattress money? Let's go through first this part, all right? First of all, if I say 1 to the 3rd power, which, by the way, could count for maybe 3 years, I multiply 1 times 1 times 1, correct? Everybody knows that rule. 1 times 1 times 1, and we get 1. Okay, all right. I get kind of crazy and I do this 12 times. Well, it's kind of insanity because I keep multiplying by 1, by 1, by 1, and nothing changes, does it? We still have 1. Now, sometimes people say, well, what about those negative exponents? By the way, that's what that is. That's a -2 on that, for those of you who want to kind of get a little better view of that. And that simply equals 1 over the reciprocal. Well, guess what? 1 to the 2nd power is still 1. 1 over 1, all for 1, 1 for all. There we go. So that's the first thing I want everybody to notice, all right? We have a lot of 1s going on here. Now, let's go and talk about Joe and his mattress here, all right? Actually, let's talk about another young lady or another guy here, another person. Let's see who we got. We got Carol coming up here. And she is going to invest $1,000 into an account or a fund that is earning 5% on average each year. How much does she have after 5 years? All right, so we have Joe who didn't get any interest, kept $1,000, but we got Carol who's going to get 5% increase every year. Now, if we're doing this annually, and that's what we're expecting to do here, all right, that means you're going to gain 5% of your $1,000 and add that on to the amount you've got in the bank or in the fund or whatever you're invested in here, all right, in your investment. Now, you're going to next take that same amount, that new amount, and you're going to increase it with 5%, which means you're going to get interest on interest, all right? Now you say, all right, where are we going with this? We're going with a nice little equation here, and I'm going to use the phrase A equals, and A is going to stand for the amount of money we're going to end up after a certain amount of time. All right, and we're going to pick up P is what we invest. In this case, it's $1,000. And it's all about 1. That's what I'm going to tell you. Money growing or money losing it, it's all about 1 here today. Well, let's see. We're going to put 1 plus whatever the rate is of growth, and we're going to raise it to the number of years. T for time, all right? So in this problem with Carol here, with Carol's situation, we're going to say, she is investing $1,000 and she is investing at 5%. Now folks, don't write 1 plus 5. You're going to make bukus of bucks if you do that because you're going to say, basically, we're going to multiply it by 6 and we'll be at 6,000. I like this kind of math. I wish it were doing that, but unfortunately, we've got to change that 5% to a decimal, and we're going to make that, notice I put the decimal in there just to kind of tip you off. It's not going to be plus 5. Sorry about that. Some of my students said, and they go like, wow, that's big money. It would be big money, I tell you. But we're not going there. We're going to have to go with 5/100ths, all right? So we're going to put that rate as 1 plus 5/100ths. And we're going to raise it up to the power. In other words, how many years did we do that, all right? So what that's basically churning through is saying, let's do the parentheses and the exponents. Remember, please excuse my dear Aunt Sally, she's back, all right? And we're going to do what's inside the parenthesis and gets us basically 1 500ths, all right? And we're going to raise it up to the 5th power, all right? Then we'll multiply that result times our $1,000 and see how much money Miss Carol has, all right? Now, before I get to her amount, let's go back to Mr. Joe, all right? Mr. Joe put his $1,000 under a mattress, into a safe deposit box, in a safe where nothing could get to it, nor could it get out and do anything, all right? So his rate is 0. So guess what? He is sticking in there 1 to the 5th power. He didn't gain anything, but he didn't lose anything. So remember what we said earlier, 1 to the 5th power, 1 to any power is 1. So his amount stays the same. Bet you didn't know mattresses knew how to do compound interest there, okay? When we're not giving interest, they do a pretty good job, all right? So again, our value here, as we said, stays 1,000, did not change. Now over here, we've got Carol popping it in, and I'll tell you what I'm going to do. Hang on just a second, guys. Let me clear that out. Let's do the calculator on this one, because that's getting rather messy. When I've got to take 1 500ths, or 1.05, and raise it to the 5th power, whoo, things start happening. So let's see. Let's put our 1,000 in here. By the way, this is one of the great things about the calculator. Put that parenthesis in there. I love those parenthesis keys. And let's put, we already know that 1 plus 0.05 is going to give us 1.05 or 1.05 or 1 500ths. So let's look at it and pop it in there. And let's see how much money we're going to get. Now that would be what would happen if we did for 1 year. Folks, we're doing it for 5 years. So here, watch where let me let you all follow that cursor there. Right there is the place where it's going. That's where the exponent key is. So we press that exponent in there, and we push a 5 down. It's going to be amazing. Let's see what she gets. Wow, we have a pretty good bit of money. Definitely more than 1,000. And by the way, since they usually take off to just cents, I don't know many places where they give you 0.281563 for your cents left over. You're just going to call it 28 cents, all right? So here's what our amount actually is $1,272. And there we go. Got a whole bottom out there to look at. And 28 cents. So that's the beauty of compound interest, okay? Now, some of you are going like, well, if we said 0.05 times 1,000, that would be 50. And if we did that for 5 years, it would be 50, 50, 50, 50 if it was not compounded, all right? So in other words, if we just went back and waited at the end and did the I equals PRT formula, we would have had looks like 12, let's see, what would it have been? Raise that, look, by 1250. And you gain a little bit more. Now you say, well, that's not a lot. But if you keep things in there for many years and you get a better rate, perhaps a better rate, that thing will shoot pretty fast. It will move and grow, and it's the best way to let it grow, all right? Compounding gives you a little bit of extra because you're getting interest on the interest. And trust me, they really sock it to you when you've got to pay that interest on a car or on a house, that kind of thing, or property, all right? So just get ready for it. It's the way of the world. It's the way of the world. Now, what about this guy James, all right? We got James here. And he is going to invest $1,000 into a fund that doesn't do so well, all right? He loses an average of 5% each year. How much money does he have after 5 years? Okay, folks, we're going back to that same formula. The amount he's going to have, and remember we said the amount was the principal? This time when we lose, we don't add the percent, we subtract. In other words, we're going to start with 1. Whole thing is about 1 today, all right? When we work with growth, and we're going to call this thing called a decay function, it's going to be 1 minus that rate, and it's going to happen every year, okay? We're not looking at a straight line depreciation. This is looking at more of a depreciation of a depreciation, which is more of what your blue book is going to calculate you for, all right? When you take care of your auto depreciating. Did I just say your automobile loses money every year? Yes, it does. It loses money just a little bit every year. Now, let's see what James's money does, all right? Here we're going to go with the amount. We're going to look for that. He is starting with $1,000. Now, here's what's going to happen. We're going to put 1 and we're going to subtract that 500ths from it. and we're going to run it for 5 years. There's our formula, all right? Now, poor old James, it's a downhill slide. It is a downhill slide here, folks. So let's see what we're going to actually have. We're going to actually be dealing with that equaling to 1,000 times, let's go ahead and subtract that out. 95 hundredths, 0.95 as we so many like it. And that's going to raise to the 5th power. Well, some of you are going, well, Ernie, that's not so bad. That's 95. When you start multiplying that times 5, that makes a big number. The problem is, my friends, that number is less than 1. And every time you square it, cube it, 4th power, 5th power, it's going to be decreasing. It's going to get smaller and smaller and smaller. Let's go to my graphing calculator and let me show you that, all right? Let me clear out what we had before, and let's take a look at that, all right? So we've got 95 hundredths, and we're going to just multiply that times 1,000 first of all, okay? And that would be what would happen after, oops, that would be great, but that's one year too many, one digit too many. Sorry about that. How about let's try it again, 95 hundredths, and we're going to multiply it times 1,000. I was about to give you 10,000 there, James. Sorry about that. Then you would have really lost more, actually. Let's see. All right, got $950. So after 1 year, we're down to $950. Let's take that formula, 1,000, and let's multiply it by 95 hundredths, or 0.95 as you folks like to call it, and I do too. And we're going to raise that to the 5th power. Let's see now where that money has gone to. Whoa! Losing money. Losing here. What happened? Wow, we are down to $773 and a little chump change, all right? So in this case, it's not as pretty. 773 and 78 cents. Hold on to 78 cents, James, because if you keep doing this, it's going to get lower and lower. So that's the idea. That's the idea. We're losing money. We're losing money. And even the first year, he's lost $50, all right? Now you say, well, Ernie, why do people do that? Well, a lot of times when funds go down, eventually they come back up strong. If you wait for the long haul, sometimes it's a good idea to get out of them, all right? That's where you talk to a manager or a fund manager or someone who's taking care of your money, and you don't let that go too long, because notice the trend is not improving, all right? But if it starts to come back up, hey, then you can start earning that money back, and it's a wonderful world of how we make money. Speaking of growth, let's take a look at growth and decay. Let's take a look at our next problem here. It says an investment grows at the rate of 25% on average each year. Boy, I would love that. If I could increase 25% each year, that would be pretty amazing. So first of all, what is its growth equation? All right, I've not put a P in here. I'm going to let it work for $1. I want us to kind of get the idea of what would happen if we put $1 in and we did that, all right? And here we go. We're going to use our formula, which is 1 plus the rate. And we're going to raise that to time. Now remember what I said, we're investing $1, all right? So I'm not going to pretend, I'm going to put it right there so all of you will know. Here's my principal, $1. I'm starting $1, all right? Now, the question is, what happens over time? What happens over time? Let's take a look at it on the graphing calculator, all right? Let's go to y equals. We're going to show you how this is going to plot. Actually, it does plot. So we're going to say 1 and 25 hundredths. Make sure that decimal gets in there. Boy, if you put a 125, you're going to be the richest person in the world real quick, like in a year or a month or what. It'll be very fast. Well, it won't be that fast, but it'll be pretty fast. Let's see where we're going to take that. We're going to take that to the x. I said t there for time, but we're going to put x in there so we can plot this. And everybody hold your breath here. Let's see what happens. We graph. By the way, this is called an exponential growth. Exponential growth because the exponent becomes your variable. And that's nice. Look at that. Your money starts kind of slow, but then it gets really exciting and goes and goes and goes because it's compounding. Now you say, Ernie, what does all that mean? What does all this graph mean? Let's look at a trace and see what's going on, all right? At your initial point, we start with $1. That's what we're going to be worrying about. We're not worrying about negative time. We put money in and we're going to move forward, all right? So we're going to make sure our time stays positive. Although if we went backwards, that's what your little dollar would become worth. It would depreciate, all right? But let's see. We're going forward. Let's see what happens at 1 year. 2, you're at 1 1/4, which is what we started with. Notice that's your number right there. Raised to the first power, it still gives you 1.25 or 1 2500ths, or in this case, $1.25. All right, you just earned 25 cents. What happens if we go a second year? Put a 2 in there for our X. Here we go. We are moving up. We have now gone to $1.56 off that dollar. All right. Third year, keep increasing it. Enter. We're almost at $2. We've almost doubled our money, people. We've almost doubled our money in 3 years at a 25% rate. All right. As long as we keep getting interest of interest of interest. All right. 4 years. Our $1 is now worth $2.44. All right. Kicking up there pretty nicely. All right. Keep working it. Let's go to a 5. See if I can get to a 5. Here we go. We have now tripled our money. Now we've added 200% to it, but we have tripled our money by going for 5 years. We've gone maybe at $1 has now become $3. So think about it. If that were $1,000, that would make $3,000. Actually a little bit over $3,000, $3,050 the way that one's going. Let's try one more year, see what happens. Let's do a 6. And folks, you kind of get the idea. It's going up pretty fast. You want to really see some fun? Let's go for 10 years. Keep that dollar in there running at that rate for 10 years. That's a hard thing to find, though. Deals that are that good. You're at $9.31. That $1 is now worth. So make that 1,000, you're over 9,000 worth. So, boy, the rate makes a difference. Time is your best friend if you're patient. If you're patient with a growth situation. Now, that's the investment. That's the investment. So how does a graph look? It looks like it's aiming to the sky. It's beautiful. It's great. It's a great thing. Now, let's take a look at our other side of things. An investment decreases at the rate of 25%. What's its growth equation? Well, folks, remember what we said. That happens when we have that. We have A, or our amount, equaling, in this case, we're investing $1. And it's going to start decreasing at 1 minus 2500ths over time. In that case, we'll put our X in there. Let's see how that graph will look on the graphing calculator. Let's go back to Y equals. And this time, let's clear out what we've got here. In this case, we're going to say 1 minus 2500ths, which is going to leave us with 7500ths. So it's already, like 3/4. Okay, and we're going to raise that to our X power. And let's see what happens. We press enter, and we'll see. Oh, there it comes. Notice it's in a decaying fashion. It's going down, 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 and down, all right? Now, if you have $1,000, that isn't very pretty either. It's going to be going down, 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 down very quickly. But if we trace that, again, we started with $1, and as time moved on, when we started losing that money, we started losing very quickly. Let's see where we are after 2 years. 2 years, we're almost half value. Looks like we're about at 56 cents for the dollar. You hear about the dollar depreciating in certain types of markets and such. This is what you're worrying about. How much money is it really worth, okay? Let's go for 4 years if we were losing at this rate. Hopefully we would never stay in this long. We would be down to 32 cents. They probably rounded out just out of pity for you and sympathy. If you were at $1,000, you'd be getting, looks like $316.40 back from your 1,000, okay? And we'll even go a little further. 6, just keeps going down. It's kind of sad. Now, let's talk about that in terms of depreciation when you buy an automobile. When you buy an automobile, you're going to pay interest to pay it off for 5 years, 4 years. By the way, 5-year plan, avoid it at all costs. 4 years or less, 4 years or less. And if you've got the cash to pay it, you don't pay interest at all, that's the best thing. But remember, on the other side, it's depreciating. It's going down, so your car is losing value, sometimes 20 to 25% a year. Hey, all that good stuff, it's practical, but it's all about the one, all about the one. Speaking of which, we've got some great Facebook stuff going on. We want to remember that you like us there. www.facebook.com/TNLearn. And also email us, mathline@tnlearn.org. a great place for us to field your questions, and we also appreciate your comments. And some of you tell us alternative ways of doing some problems, and we appreciate that. We appreciate that. We try to present those from time to time on the show. Summer school, we're a little bit lighter weight and such. And by the way, you can always check us out on YouTube, www.youtube.com/again, TNLearn, where we put up our problem of the day during the regular season. And we're going to start putting up some of our summer shows too, that you don't want to miss out on those. So we've got some great things going on. It is summer school. The living is easy. We hope you enjoyed the show today. Hope you got something out of it. There's a real lesson to that. And we're going to do, come fall, we're going to take the growth and decay and depreciation type stuff a little bit more in depth, all right, and apply it, how did I get that word out? Apply it to your good old real world. But thanks for tuning in today. We're going to be back again next week, ready for you and every day. Take care. See you then.